Hello, Professor. This is my lab for the FPU project for this week. I'm just going to go over the code and then we'll run the debugger to see the output. As you can see, we use the Irvine library again. My data, I used a Rio 8 variable to store the height, the weight, and also the BMI. I also used three more, one I labeled obese, overweight, and normal to compare the BMI to, so I could do the proper printouts of the status. I didn't do one for underweight because that one's default. If these don't print out, then by default it's going to print out underweight. Here are my prompts. My initial prompt is to enter your height in meters. After you enter your height in meters, it squares it for you and then prints it out as well. New line is for legibility again. Prints out, it asks you for your weight. And then after you give it your weight, it divides your weight by your height in squared, and it prints out your BMI. After that, it prints out your status. And these are the prompts that for the status. Underweight, normal, it's a good job, overweight, and obese. For the code, the first part of the code is where we take the height from the user. We use the prompt, we print it, and then we call the read float, so it could print it out for you. It'll print it when you input it. No, I'm sorry. It'll read it when you input it, and then we call this prompt so it could print out this before we square it. Right here, we're squaring the floating point in the stack, in the 0 position in the stack. We're doing it. We're squaring it. We're multiplying it by itself, so it's going to square it, and then it's going to print it out. The whatever. Well, because when you square it, it's going to store the value back in the 0 position. After we print it out, we save it and pop it onto height. I'm sorry, we store it in the variable height, and then it's going to pop it from the stack. We also print a new line for legibility. After this, we take the weight from the user, and it's pretty much the same process without the square. We read the float, and then we store it and pop it from the stack. And we store it into weight and we pop it from the stack. So this is where we divide the weight by the height squared to get the BMI. So first we load the weight on the stack, and once that's loaded, we divide the weight by the height squared. This is where this is already on the stack. So this F division is going to divide whatever's on the stack 0 position by whatever variable you put right here in I believe it's the destination. And after we get that result, it's going to be stored in ST0. So that's when we call the float. We call the write float, so it'll print out what's in ST0. And then we pop it and store it in BMI. This is where we calculate and print the status of the BMI according to this table here, adult BMI. So first we print out a new line, then we print the status prompt, and we load obese into the BMI, into the stack. So that'll go into 0 position, but then we we load the BMI, which will now go into the 0 position, and obese will be in the first position. So what we do is we compare the BMI, which is in the 0 position, and then to obese in the second. So this jump is if BMI is above or equal to obese, it's gonna jump to label 1, which is down here. And then it's gonna print out the prompt for obese. And then it's gonna jump to finish. And after finish, it's gonna exit. If it doesn't jump, it continues. It's gonna pop BMI. It's gonna store BMI and pop it from the stack. And all the same thing with obese. I didn't know how to do it, so this is what I did. And for the next one on the overweight, I did the same thing as I did here. And I did that for normal as well. So we load overweight, we load BMI, we compare BMI to overweight. And if it's above or equal to, if BMI is above or equal to the lower, which would be for overweight, it'll be, if it's above or equal to 25, it's gonna jump to out 2. Otherwise, it's gonna continue. And out 2 is just gonna print out overweight, and then jump to finish to exit the program. Otherwise, it's gonna store into BMI and pop it from the stack, and then same thing with overweight. It's gonna store it in overweight and pop it from the stack. We do the same thing for normal. It's gonna jump to L3 and then print out normal. Good job. And then jump to finish from there. If none of these pop, if none of these jump, then we continue on, and then we just print out underweight. And then from there we jump to finish, so we can skip these labels. And from finish, it just exits the program. So that's the code part of it. Let's do one example, and we'll use my height and weight as input. So my height is approximately 1.73 meters. So here it squares the height on its own, and we get 2.99 meters. After that, it asks us to enter our weight in kilograms. So that is approximately 68.1. So here, after that, after we give it our weight, the program divides our weight by our height, and it prints out the BMI in exponential form, I guess. So it gives us 2.275, which is in exponential form. So it's 22.75. If you use this table, I fall under normal. So the status equals normal. And I left good job for normal because that's ideal. That's where you want to be. But let's do one more just for showing different outputs. Let's use one for obese. Let's use 1.76 meters, and then 136.25 kilograms. And as you can see, it gives us a BMI of 43.98, and the status will be obese because it's above or equal to 40. So that is my program, Professor, for the week. Thank you very much. I'll see you in class.